Okay, so let's discuss structs in Rust. Now the first thing you need to know about structs is that they are quite similar to tuple. You should check out this video where I explain how tuple work, including how it is part of compound types in Rust. Okay, I explained in detail how it works and how to use it, but they are quite similar. Okay, with struct. For example, you can store a location. You know that locations are made up of longitude and latitude, and that they are usually floating point numbers. So you can define a location variable where you're going to store a type of each coordinate will be of type f64 for the longitude, and then f64 for the latitude. Okay, and then you can then type in the values. Let's say 44 points, that, and then this. Okay, now we've defined a location which as a tuple where we have the longitude and latitude, and we've defined their values here. The problem with tuple is that it doesn't give you specifics. The first question you have to ask here, you'll find yourself asking here, is this: why do we have which of this is the longitude and which of this is the latitude? Okay, so it's very confusing. Now with struct, on the other hand, it makes it a lot easier to understand. First of all, if you came from other languages, structs are like classes in other languages. So to define a struct, all you have to do is to use the struct keyword, and then you type in the type. Okay, I remember that both the struct and the tuple and all that, they are just types, data structures, how you can formulate data. For example, here we've formulated this data in a tuple and arranged it that way. Okay, so to create, let's call this struct location. You start creating a struct with capital letter. Okay, and then you open curly braces. Yeah, in fact, you can even remove that curly braces. You can create a struct this way, but nothing is inside it. We've not defined anything. So if you open up with curly braces, then you can now start providing some values. For example, here we will provide longitude. Okay, and we'll say it's of type f64, and then you separate it with comma, and then you provide the latitude, and then say it's of type f64 as well. Now notice that we are separating each field in this struct with comma. In other languages you usually use a semicolon, but here you will use comma. That is the first thing you have to notice. Or the second thing you need to understand is that these are called fields. Okay, each of these values are called fields in Rust structs. In other languages you call them properties, but here they are called fields. We can now get an instance of this location struct by calling, let's say, create a variable that we'll call location 2, and then we say it's of type location, this new location that we've created, the new type, and then we define an instance of it. Okay, let's say we say the longitude will be 45.63, and then the latitude will be 56.78. Now, another thing you have to notice here is that we did not use the new keyword as we would do in other languages, so it's not necessary. And then the second thing you have to notice is that we use curly braces after we've typed in the name of the struct. Okay, in other languages you will use a parenthesis, but here you use curly braces. Then the third thing you have to notice is that every single value you provide for the struct fields will be separated by comma, while you will use a semicolon in other languages. And then the third thing you have to notice here is that when this was created, or as this is created, there is no constructor here. In other languages, when you create a new instance of a class, you usually need a constructor in order to initialize the fields, the properties you have. But here you don't need a constructor. just type in the name of the struct, provide some curly braces, and then provide the details for the fields that you have there. Now it's a lot more clearer. Okay, this is better than using a tuple, because now you know what is longitude and you know what is latitude. Okay, now another similarity structs have with tuple is that you somehow access them the same way. For tuple, you access them using the dot notation. For struct, you also access them using the dot notation. So for example, for this struct location, you can access the first value by typing in location.0. Okay. However, for location 2, which is an instance of the location struct, you can access the value by using the defined fields. Okay, they are named, and that is the advantage they have. If you want to get this longitude, you can just type in long. Okay, and if I print this to the terminal and then run the code, oh sorry, we have to access location 2, which is the instance of the struct, and then we run the code. You see that we got longitude equal to 46.63, which is exactly what we provided here. Sorry, 45.63, which is exactly what we provided here. For the latitude, to access the latitude, we will have to use lat, which is the name of that field. And then if you run it as well, you get the value 56.78, which is exactly what we provided here. Okay, so they're quite similar. They both use the dot notation. Okay, while this one we use indexes, which will start from 0. The struct we use the name of the field. Okay, if you want to access it. Perfect. Now also notice something, that when you create an instance of a struct, you provide the name of the field and then provide its value. And this is a huge feature in Rust that other languages are beginning to introduce. Okay, named, they call it named parameters, where you provide the name. This way you no longer have to, you can provide the longitude, the latitude first. You can provide the latitude first and then the longitude first without issues. Okay, it makes it possible for you to do it in any order you want, which is very beneficial. In other languages here, you don't have this feature. You must provide the first one first and the second one first. And if you introduce new variables, it becomes a lot problem. Or if you make the mistake of adding a new variable first, it will then shift the positions of these ones. Okay, and will start causing issues. But this way, you provide the name and then you provide the value. It makes it a lot easier to understand. Okay, so now let's focus on structs for now, because that is the purpose of this video. I'm going to remove this tuple definition and let's focus on this one. Okay, so in Rust there is something called the field init shorthand. Okay, it's this idea that if you have a variable, let's say longitude, let's say we have this variable called long right here. It represents the longitude and its type is of F64, and we assign it to this value. Okay, now the idea of this field init shorthand is that since the name of this variable and the name of this struct we are instantiating here is the same, they have the same spelling. Okay, you can use this instead of doing something like this, long. Okay, this will work because you're setting this long field to this long value here. But since they have the same name, you can just leave it out and type in the long directly. Okay, and no longer have to provide the value separately since they have the same name. So it's called the field init shorthand. It makes it's like a shorthand of doing this. This is what you can do with in JavaScript when you have an object whose whose item has the same name as a variable. Okay, you no longer have to provide the key separately and the value separately. It's kind of what we did here. They have the same name. You just use that name struct without having to do this extra assignment that we did here. Okay, having the same spelling does that trick for us. So it's called the field init shorthand in Rust. Okay, now so let's check out another feature of struct in Rust, which is called the struct update syntax. Okay, so it's this idea that if you have a struct instance like we have here, and you have another struct instance of this location again, and you want to copy some part of these values, then you can just copy just the part you need and then reuse what you have in the other ones. Okay, let me give you an example. So now we have a struct that we call user that has just two fields, the name and the ID, and both of them are of type string. Now let's create two instances of this user struct. Now we have two instances of this struct called user1 and user2. User1 has the name Henry, which we got a string slice and then converted it to a string. And the same thing for the ID, we got a string slice and we converted it to a string object. Okay, now for the second user, we set the name to John and then the ID to this. We use the string, the from associated function and string, and the string struct to create the name and then the ID. Now let's assume that for this second user, we want the name to remain the same thing, but we want the ID to change for some reasons. Once we remove that name, it will start warning us because we are supposed to say it will say missing struct fields name. You are supposed to provide the name. Now we can say the name and then we assign it to what we have, the second name we have here from the user. Okay, so we can say user1.name. This way we have assigned this user. It's like we've copied the name from this user to this user. Okay, now there's a shorter way to do this, which Rust calls the string update syntax, which is it will say provide the new values you want and then add the old value that you want to reuse. Okay, now what we can do is we provide the new values we want to provide and then reuse what is inside the old values since they are of the same syntax. For example, this one is called user1, so we can just provide user1 here, and then before it we use this syntax that looks like the range syntax. Okay, 2 dots before we provide the name. Now it is important that you provide this last after providing the new values. Okay, if you come from JavaScript where you have something like the spread operator, okay, it's recommended to do this first before you provide the other values so that the new values will overwrite what you have in the old values. But in Rust, you have to provide the old values last after providing the new ones. Okay, so once we've done this, we succeeded in copying what we have from user1 to user2 while replacing just the few we want to replace. Okay, now another problem with this thing is that you have to bear in mind that we are moving the values. So since this name is a string object, it is stored in the heap, it will be moved and not copied. Okay, which simply means that this user1 variable, after we must have reused it here, moved it here, we can no longer use it because it's now invalidated by Rust. Let me give you an example. So if we try to access user1 and then we try to access the name again right here, for some reason Rust will start warning us, and if I hover over here, it will say use of moved value user1.name. So if you do something like this, reusing what you already have here, bear in mind that the value will be moved, and therefore this whole instance can no longer be used. Okay, I explained this in detail when I explained the ownership rule in Rust. You have the borrow check and make sure that if you borrow something to someone, you can no longer reuse it. Check out the video here to understand fully how that works. But that is how it is. If you're going to use this struct update syntax, bear in mind that the value will be moved. Okay, so that's it for today. Subscribe to get updated once I update new videos. I update new videos on this channel every day. Thank you.